You're welcome to this channel. My name is Jake Anemo, and this is OnlineMaths TV, okay, where you learn mathematics every day. Today we have a challenge on the board. But before we go into today's challenge, if you are new to this channel, kindly subscribe. And when you subscribe, turn on the bell notification button so that YouTube can use this algorithm to notify you whenever we drop a new video. In other words, you will be among the first person to get our videos when they are released. So let's go into today's challenge without much waste of time. The question says 27 to the power of x plus 12 to the power of x equal to 10 into 8 to the power of x. What then will be the value of x? This is an exponential equation. So let's go to this journey. So from here we have solution. We write down our equation of 27 to the power of x plus 12 to the power of x equal to 10 into 8 to the power of x. Okay. From here, the number one thing we're going to do here is simple. We eliminate this 8 to the power of x. In other words, let's divide through by 8 to the power of x. So we'll say here, divide through by 8 to the power of x. And so we're going to have here 27 to the power of x all over 8 to the power of x plus 12 to the power of x all over 8 to the power of x equal to 10 into 8 to the power of x all over 8 to the power of x. Of course, 8 to the power of x will take care of 8 to the power of x, and here we are left with 10 on the right-hand side of our equation. Yeah, look at these expressions on the left-hand side of the equation. According to the law of indices, which says if you have a to the power of m all over b to the power of m, this is equal to a all over b all to the power of m. So if we succumb to this rule, this expression can be written as 27 all over 8 all to the power of x plus 12 all over 8 to the power of x equal to 10. Very easy. Okay. We now begin to think. Okay. So what we do here now, we now begin to observe. Is there anything that can go into this? No. But is there something that can go into this? Yes. 4 can go into this, 4 can go into 8. So how do we now deal with this? Yeah, 27 can be expressed as 3 to the power of 3, and 8 can be expressed as 2 to the power of 3. So we go ahead and do that. So this is same thing as 3 to the power of 3 all over 2 to the power of 3 all to the power of x plus 4 into 12 will give us 3 all over 4 into 8 will give us 2 bracket all to the power of x equal to 10. So let's proceed from here. Okay. Now, look at the expression we have here now. This, if we succumb to that first rule, okay, of indices, this can be expressed as, here we have 3 all over 2 all to the power of 3 all to the power of x plus, here we have 3 all over 2 all to the power of x equal to 10. Good. Now, we are having 3 all over 2 to the power of x. We want to bring out 3 all over 2 to the power of x here. So if we look at this expression, according to our indices, it said if we have a to the power of m bracket all to the power of n, this is same thing as a to the power of mn, which is equivalent to a to the power of n bracket m. So if we succumb to this rule, we can rewrite this expression as, here we have here 3 all over 2 to the power of x all to the power of 3 plus 3 all over 2 all to the power of x equal to 10. Very nice. We are having 3 all over 2 to the power of x, and we're also having the x. So at this point, we can now say, let's say y equal to 3 all over 2 all to the power of x. Whenever we see 3 all over 2 to the power of x, we put down y there. Automatically, we're going to have here to be y to the power of 3 plus y equal to 10. So if we recollect or rearrange our expression, we have here y to the power of 3 plus y minus 10 equal to 0. Okay, now this is a polynomial equation. Okay, so we solve this. We can use 2 methods to solve this polynomial. Okay, I can use the trial by error method to solve this, but I'm going to use a different method in solving this. I want to introduce 2 entities that when you sum them up to give you plus y here. And if you go by that, we can have this to be minus 4y and plus 5y. So if we go by that, we can now have this to be y to the power of 3 minus 4y plus 5y minus 10 equal to 0. It has not really changed the system. So we go again. We can put this in a bracket, put this in a bracket. So if we do that, so let's bracket x, bracket x, bracket x, bracket x. And so we can factor out y from here. If we do that, we're going to have here y bracket y squared minus 4 bracket plus what is common here is 5. So we have here 5 bracket y minus 5 into 10 will give us 2 close bracket or equal to 0. All right. Look at this. We're having y to the power of 2 minus 4. We can put in 2 here to the power of 2. So if we do that, we're going to have this expression to be y bracket y to the power of 2 minus 2 to the power of 2 close bracket plus 5 close bracket y minus 2 close bracket or equal to 0. Very good. So let's proceed from here. If we succumb to the law that if we have a square minus b square, this is equivalent to your a plus b close bracket bracket a minus b. Okay, so if we have this, we can bring this expression to this form. Okay, so if we do that, this expression we have here will now thus become, this implies y bracket your y plus 2 bracket bracket y minus 2 then plus 5 bracket bracket y minus 2 or equal to 0. Now from here you discover that we're having y minus 2 and y minus 2. So we can factor y minus 2 out. If we do that, we're going to have here to be y minus 2 bracket bracket into a square bracket, your y bracket. We are left with y plus 2 here, okay, plus, here we'll have 5 here, close bracket or equal to 0. But before we continue again, if you are new to this channel, kindly subscribe. And when you subscribe, always turn on the bell notification button, okay? Because we drop new videos here every day. So let's go back to the board. Now, we have succeeded in bringing out y minus 2 in this system now. We can now open what is inside here now. If we use y to open up this, then we now have here bracket y minus 2 close bracket bracket y squared plus 2y plus 5 equal to 0. Very easy. Now let's look at this now. We can succumb to the zero product rule again, whereby we equate this to 0, equate this to 0. So therefore, we're going to have here y minus 2 equal to 0 or y squared plus 2y plus 5 equal to 0. Okay, so from here, we don't have issue with this other side. Here automatically will give us y is equal to 2, positive 2. So let's solve for this other side of our y, which is y squared plus 2y plus 5 equal to 0. This is a quadratic equation. So we solve this quadratically. So from our quadratic equation here, let's check if this guy will give us real root. Okay, so we use the determinant factor, which is the square root of b squared minus 4ac. If we do this, this automatically will give us, let's write it on this other side, this automatically will give us our b is 2, so we have here 2 squared minus 4, our a is 1, and our c is 5, so we have here 5. So automatically, this will give us 4 minus 20. And this will in turn give us root minus 16. So automatically, this will give us imaginary root. And we don't want the imaginary root here. We're only solving for the real root. So let's go to the first root, which says y equal to 2. Okay. So if we succumb to that answer, so we have here y equal to 2. So let's recall that we said let y equal to 3 all over 2 all to the power of x. So from here, we now have this to be 2 equal to 3 all over 2 all to the power of x. At this point, there is no way or there is no how we put 3 all over 2 here, raise it to a number to give us 2. Okay, so that we can cancel out same base. Since that will not work out, then let's introduce a natural log, which is the in to both sides of the equation. And so if we do that, this is going to give us here the in2 equal to in3 all over 2 all to the power of x. According to the law of logarithm, says that if you have in p to the power of k, bring this k back to give us here k in p. So if you succumb to this rule, this will give us in2 equals to x into in3 all over 2, close bracket. Make x the subject of the formula. And so x is going to give us here in2 all over in3 all over 2. So from here, if we simplify further, according to the law of logarithm, this is a division. Okay, if we apply the division rule, it's going to give us here your in2, okay, all over your in3 minus in2. Okay, so this is the value of s. You can go ahead to punch this in your calculator. Whatever value you're going to have, if you put it into our initial equation, which is the original exponential equation, you are going to have the correct answer from this. Okay, so this is the final answer to our exponential equation. Okay, if you have learned something good from this exponential challenge, drop it in the comment section. Okay, if you love what is happening here, you can give our video a thumbs up because it helps to fast track the growth of this channel. Okay, and also if you have a better way of solving this, also drop it in the comment section below so that we can equally learn from you, because we are here to strike a win-win situation. Okay, and at the same time, you notice an error in the process of solving, do not hesitate to drop it in the comment section. Okay, so thanks so much for always being there. Remember, IJX loves you so much, and all of us at OnlineMaths TV love you so much. Thanks for always being there. Bye for now.